Hello everybody and welcome back. We're looking now at question 17 on our 2010 Fermat paper. In the diagram, PQRS is a rectangle with PQ equal 5 and QR equal 3. PR is divided into 3 segments of equal length by T and U. The area of quadrilateral STQU is... Okay, so I want this area in here. And so I start to think, well, how can I figure out this area? Now, I strongly suspect this is a parallelogram, but as it's not a parallelogram that I can immediately see good ways to calculate its values, I'm going to start thinking about other ways to do this. I mean, maybe I can, but, Certainly, I strongly suspect due to the symmetry, now that I've shown what the shaded area is, I'm going to get rid of it. I strongly suspect due to the similarity that this must be a parallelogram. And I seem to recall there's some way to get the area of a parallelogram in terms of its 2 diagonal lengths. Somebody down in the comments can correct me if that's wrong, but off the top of my head I think there is. But I don't know what it is. So I'm going to look for a different way to get the answer to this question. I think what I'm going to do is I'm going to take each of these 4 triangles away from the total area of the rectangle. I think that might be perhaps the safest way to do this. If I think of another way in the midst of the question, I might shift to that, but that's currently my attack strategy. So we'll copy their picture over and we'll start marking it up a little bit. Now 5 and 3 aren't nice numbers for figuring out the length of PR, this hypotenuse here. So I don't really think I'm going to need that. T and U. So I think I'm going to take 3 times 5, 15, which is the total area, and I'm going to subtract off these triangles. Okay. Now, the sides of a rectangle are parallel. So by the Z theorem, parallel crossed by the same point, you get a nice little backward Z here. We get the same angles there, and similarly you'll get same angles here. And 2 angles in common. You're going to have the third one in common. They both have the length of 5. So this triangle and this triangle are the same. This triangle and this triangle are going to be the same by similar reasoning. It's not a written contest, so I'm not going to even start to write out, oh, this is similar to this, but there's our intuition. So I really only have to figure out the areas of the green and blue triangles. Alternatively, I guess I could figure out this triangle right here somehow, but I think that would just be using the PQR and subtracting off the green and blue triangles. But, okay, how am I going to do that? Alright. So, I know the bases of these 2 triangles. I've got a 5 up here and a 3 over here. So that works out quite nicely. But then there are these points here. T and U. Now, if I drop from T, let's call this V, the shortest distance from T to V would make a height for this top triangle, and that would make a nice little right angle. And so we'd get a similar triangle. PTV would be similar to PRQ. And by the same reason, if I take U and I drop a perpendicular here to, say, W, URW is going to be similar to PRQ. So, what can we do here? I know that PT is 1/3 of PR. Oops. Not RR, PR. And similarly, since T and U split this up into equal pieces, UR is that same length. It's going to be 1/3 of PR. Now, because these are similar triangles, the ratios of their sides are going to be the same. So this side, RW, which is similar to the big side RQ, it's going to be a length of 1/3 of RQ. Same with this length here. And we're also going to get 1/3 of PQ and 1/3 of PQ here. So I can actually figure out the heights of these two triangles. It's 1/3 PQ, so 5/3, and then 3, and a base of 5 up here, and 3/3, or 1 here. So I'll take 15 minus 2 copies of the blue triangle that has a base of 3, so 1/2 base times height, and then minus 2 copies of the green triangle, which is 1/2 base of 5 times height of 1. Okay, 3 and 3 will cancel out, 2 and the half will cancel out, 2 and the half will cancel out, so I'll get 15 minus 5 minus another 5, and I will get 15 minus 10 is 5. I wonder if there was a simpler way to do that. Figure out that this black triangle here must have been 2.5, but I honestly can't think of a way to notice that. Well, I guess all the triangles were 2.5. It split the area of 7.5 into 3 equal parts, and I don't think that's a coincidence that T and U split the hypotenuse here, or the diagonal, into 3 equal parts. But no theorem is immediately coming to mind. Of course, it doesn't need to. I've got my answer already. The answer is going to be B5. So we can just bubble it in and move right along to our next question. Question number 18. We'll be taking a look at that in the next video.